we need to talk about effect on the front end. Effect has been blowing up recently, and it's super exciting, especially for the back end, but things get a bit more unclear as to where it really makes sense on the front end, if at all. There's a lot to talk about here, from the differences in problems on the front end versus the back end, why you would want to use effect on the front end in the first place, and if you choose to do so, what are the good ways and the less good ways to do that. So let's go to Excalidraw to break this all down. I want to start this off by, just reiterating why effect is so good on the back end in the first place. And I think it really starts with like the typed errors and dependency injection. This is like bread and butter of effect. You got that effect type, foo error or bar error requires foo service and bar service. And this is like a huge kind of level up in developer experience in terms of, error handling and writing like testable kind of composable code. And then after that, you have like all this like advanced async, I'm just gonna call this like stuff, right? So this is things like timeouts and things like retries, fibers, there's STM, there's queues, this kind of goes on and on and on. And this stuff, you kind of don't need it until you really need it, and then it kind of gets really hairy between promises and callbacks and abort signals, and effect makes that super easy. Then of course we have telemetry, and this is another kind of advanced use case. You start out, you don't really need it, and then at some point it becomes really important and you have to go back and wrap every single function in your entire code base in a span, and effect also makes that really easy. And then finally we have like a huge standard library and ecosystem packages. So this is things like the HTTP API, RPC, CLI, platform, and these just make it really easy to build these kind of like big backend apps with effect. And a lot of these things, can apply to front end, but front end generally has just a different set of problems, right? So what's hard about front end? Really a lot of front end is about mainly state management and kind of reacting to push-based events and this like word reactivity, right? So reactivity is like everything in front end. We have like React's model, we have like signals models. There's like, you can have stores, or you can have atomic based state management. You can put your state in React, you can put your state outside React. And a lot of the problems are just about keeping state synced and also like async state, right? So if you're like making a fetch call, those are like 5 different states there. You have the loading and revalidating and error. And this is really hard. And then another thing that really matters here a lot is bundle size, right? We can only ship so much JavaScript, or we can ship more and things kind of take longer to load. And this does have some kind of concerns when you look at the things that effect does, right? So while some of these map, right, like having typed errors is nice on the front end, but generally it's not as nice, right? Like a lot of the times on the front end, you can just get away with having like something went wrong. Not to say that your experience can't be even better for your users, but that's kind of like most people just have that right now and you can kind of get away with it. There's not as much advanced async stuff. I mean, I would say there actually kind of is, but it's kind of pushed into libraries, right? Like React has its own fiber model where it's doing a lot of this like stuff inside of it, and you just kind of think about rendering your state. Telemetry also can be important, but is like, you're not really kind of instrumenting every single span like you are in the front end. And then, having this like huge standard library is like obviously can actually become a concern when we start caring about bundle size. So given this framework, right, why would you want to use effect on the front end? And I think reason number one is you use effect on the back end, right? And you can kind of think of this similar to TRPC, where if you use TypeScript on the back end, you have a lot to gain by using TypeScript on the front end too, right? You can share types, you can share libraries, you can have this kind of very coupled relationship, and then things can kind of just beautifully flow from front end to back end. You change like one file on your back end, you get a type error on your front end, and it's the same with effect. And with effect, I think this kind of even multiplies more, because now on the front end to the back end, you don't just get success types, you get error types flowing. And effect has these schemas where you can like define the serialization boundary, and you can also get like the telemetry kind of automatically just works. So you like have your telemetry on your back end, and now you use effect on the front end, and you get these like beautiful distributed spans from like front to back, this like distributed tracing. And so there's a lot of like compounding benefit if you use effect on the back end. And then really the other reason that you might want to use effect on the front end is you're doing some really complex shit. So a lot of front end, like I said, is just kind of, call API, do some stuff, render, markdown. But some people are doing some really cool stuff. So there's this thing called LiveStore, which is Johannes Schickling's kind of like sync engine, and there's all kinds of like workers and IndexedDB stuff, and he's using effect for this. I could also imagine you have like a like really crazy client SPA with just some like wicked async stuff and extremely complex error states and lots of like dependencies that you want to be testable. And there, I think it makes sense. And also those kind of apps, bundle size starts to matter a lot less, right? Where you have these kind of like SPA local first apps where you're kind of expecting a really large bundle to begin with. So now, given that you're going to use effect on the front end, there's kind of like a lot of options, right? There's like this like spectrum of your options. And on the left, we have, I call effect like it's just another function. And I'll talk about what this means in a second. And on the other side, we have effect is my framework. And so over here, I think on the most left side, we just have like calling run promise in onClick. So this is what this kind of looks like, right? We have a button and we call run promise on some like effect logic. And this is a way you just like have a function that uses effect and you kind of use it in this one very, very isolated spot. And, at this kind of run promise boundary, you basically like lose all your type safety. Like this could throw like kind of any other handler. You're not really doing anything with that error. Maybe this one function is like really complex, or maybe it's calling an effect API or something. And, in theory, a lot of the things that you're doing in effect are async. So you have this problem of like managing async state. And so this is things like having a loading and success and error state. We have like revalidation / retries / invalidation. Then we have things like optimistic updates, so you can like update the UI before this kind of async action has completed. And then finally, you need to consider like doing like SSR and hydration. And so if you look at this kind of list of requirements, you might think of a library immediately that kind of addresses all of these, and that's React Query, right? Like React Query is like the async state library for React. And so something you can start to do is you can call run promise in React Query via use query. And this will kind of start to take care of this. Running run promise in use query can actually be a really good way to start using effect in React. It can kind of explode in complexity very quickly. And let's take a look at why. So here I have a very basic example where we have a use query and it's just calling some API. And I also have this one called use post effect. And what this does is instead of just like calling the function directly, we call effect.runPromise. And this is just like some effect that kind of succeeds with some posts or has this unknown exception. And if we switch this out, you'll see that everything just kind of continues to work. But there's a lot of like kind of very subtle things that are wrong here. So the first is that we're not actually correctly interrupting this. So React Query has this like abort signal, so we need to remember to pass this in to the effect run promise. And then the other thing is that we're missing out on error handling, right? So this has a typed unknown exception. But if we look at the error that we get back from use query, it's just this kind of opaque error object. And something we can do is we can kind of wrap this in effect.either to move the error. So if you don't know what effect.either, it takes an effect and kind of moves the error into the success channel. So now error is still error, but this would actually like basically never happen. And instead, data now is this typed unknown exception. The problem here is that this like fundamentally breaks React Query's model, because whenever this function, the query function, succeeds, React Query assumes that that is like a successful kind of like run of that function. But what's possible is that this function fails, and so the either is the kind of error variant, but then the React Query sees that as a success. And this means that React Query is going to store that in the cache, and it's not going to retry it behind the scenes, right? Because, like, for example, if this query function throws, then it's not going to store that in the cache, and it's going to like keep retrying that function until it succeeds. But because kind of effect is really fighting this model, you kind of run into some problems. So one solution to this is to make your wrapper even more complex. And I did this in this like effect React Query package. So I have this thing called like make effect React Query or make use effect query, and it returns this function called use effect query. And the way you would use this is here. Let's see if we can actually install this. So here's what using my like own kind of React query effect wrapper looked like. So you called this use effect query and you gave it a function that kind of had some effect, and you would get this fully typed error. And actually it was really cool where because in effect you have like expected errors and unexpected errors, which are described through this cause type, that the error is a cause. And then what you could do is you could also, there was an option called, I think it was like throw on defect. And what this would do is it would change the error to just the typed error. And then if it was an unexpected error, it would throw, so you could like catch that with an error boundary and give a more like opaque error. And this is like pretty cool. It takes a lot of work to make this happen. And then the other thing is that you have to manage like the runtime, because the effect has like these layers, and layers can be async. And there's like a lot going on. And it's also really complex because in effect query, the like properties that you access from the query result kind of subscribe to them. And so you don't want to just kind of like read all of them. So you have to like create this proxy, and it's just a mess. So this effect in React query thing can work. And what's great about it is, right, it's easy to start, but it's probably a bad idea long term. And really one of the biggest reasons for this is, one, there's just a lot to maintain, and it just like fundamentally breaks React query's model, which is expecting that you give it a function with a promise, and if that promise rejects, that's an error. And this can really start to be bad when you have like query composition, right? So if you want to use the result of one query in another query, because something that React query will do is that the result of the first query will throw with this like canceled error. And this is like caught by the outer query because it's like a class that React query like catches for and checks against. But this is like not part of their public API at all. And so it's like becomes like increasingly hard to kind of integrate these two separate worlds. And so if React query is not the best way to kind of go about things long term, what are the other kind of options we have? Well, I think it's worth noting that like these first two options I would describe as like pass state into effect, right? So let's make this like green or something. So these are path state into effect. So we have our React state, and we're passing the state into the effect, and we're like calling a function that returns an effect that kind of we like consume the React state through that. And the next thing that we're going to do, this kind of other option, is that effect is the source of state. And this is kind of a very different model, right? Where the state comes from React itself, and then React is actually like hooking into that state. And so this is where it's important to mention this other library called effect Rx. Now I know a lot of you are going to get very scared about this Rx name. I promise it has nothing to do with RxJS. Like it is also reactive, and RxJS is also reactive, but like different things. They're both reactive. So effect Rx is this library from Tim Smart, who's one of the lead maintainers on Effect, and it's a reactive state management library for Effect. But what does that really mean? Well, basically, effect Rx is effect Jotai. That's basically what it is. It's effect Jotai. So if you don't know what Jotai is, it's this library from Poimanders, which takes an atomic approach to state management. So you can create these things called atoms, which are kind of like individual pieces of state. And then you can have atoms that are like derived atoms. So you can have like an atom that reads from other atoms. And then if those atoms change, it kind of reflects the change. And then you can have like atoms that are writable, and they can like write to other atoms. And you kind of create this like whole like dependency graph where if one thing's changed, like everything upstream's changed. And then you have these hooks called like use atom, where React can kind of hook into the atom state and kind of read and write to it. And effect Rx operates in a very similar way. But there's a couple things you should know about Rx. And the first is that it's highly experimental. So this is like, not a lot of people are using it. The API is changing all the time. But it's kind of, I think it's in a really good place where it's worth trying out, and it provides some very distinct benefits over these kind of other models, which we'll talk about in a second. Besides being experimental, it has a agnostic core and framework specific hooks. So this is very similar to Jotai, where you like declare these like these atoms or these Rx's, and then there's like a Vue way to hook into these, and there's a React way to hook into these. And I'm sure someone can make a Svelte library. Maybe Ben Davis will do that, hopefully. Again, also like Jotai, it has a atomic state model, like Jotai. And one of the other things it can do is it handles async state. So here, let's just draw a little line like that. Now, Jotai can also handle async state, I think, here. So yeah, so you can have like an async atom, which gives you like a loading, has data, has error state. And this is basically like, we have React Query at home, right? But Effect Jotai, or not Effect Jotai, Effect RX kind of does the same thing. The final thing is that it's Effect, I'm gonna call this native, right? So there's a lot of like Effect things that, like I said, where when you try to merge React Query's model and Effect's model, you kind of like, you run into a lot of friction. Where with Effect RX, like everything like just works, right? So it supports effects, like, understands runtimes and effect scopes and streams. So these are all things that, like if you have async layers, or if you have a runtime that you need to construct, if you have an effect that has a scope, if you're using an effect stream, Effect RX is like built to kind of work into that by default. And the other thing that's really cool that it does is it can kind of integrate with the effect scheduler to with the React scheduler. So I tweeted about this the other day, but if you go into Effect RX and then you go to packages, RX React, source, registry context, it implements the schedule. This is the scheduler package, is what React uses internally. And is able to schedule effect tasks as low priority so that they don't block rendering, which is really cool. The other thing here is integrating with React-only state can be hard. And this is really no different from Jotai. But when you kind of have these models where if you're using an external state library, so something like MobX or Jotai or Jusand, these are things where the state lives outside of React, and sometimes you need to kind of integrate those with state that only lives in React. So a good example is like if you have a like use user hook, which reads from some auth context, there's no way to kind of like put that natively in Jotai. And so your options like here are basically you can pass state into Jotai or into Effect RX, or you can try to like make an atom or make an RX that like in a use effect is constantly syncing with the React state, which is like less ideal. The final thing on the framework here is like Effect is my framework, and then there's this thing called typed /fx. So this is a library from Taylor S. Is this it? Yeah. So this is like a highly experimental, like basically React replacement, and it's built on this concept of this thing called an FX, and an FX is basically like a push-based reactive primitive. So this was one of the things I talked about earlier. Like on front end, a lot of things are push-based, right? Like on click is a push-based event, or on scroll is a push-based event, and the kind of effect model in the back end, you kind of have less of these, and so typed is kind of an experiment of what if we like went all in on effect, our rendering is effect, our context is effect, everything is effect. And this is like, I wouldn't use this. I would try it out, but this is kind of like, if you went all the way effect, what could that look like? But I think Effect RX is probably the best middle ground for now. I've been doing a lot of work on Effect RX recently. So this is like, since I started working on this 3 weeks ago, there's been a ton of PRs. I added refresh on Windows. So there's a lot of things like that came from React Query that I kind of have brought to Effect RX to kind of bring it up to the same level. So one of the things that React Query does is, here I can pull this up, is by default, when you go back to a tab, like if you switch tabs and go back, it will invalidate all your queries and kind of refetch them behind the scenes. And I added this to Effect RX. I added hydration support, I added streaming hydration support. We just added optimistic updates. And these are super exciting. And then actually the last thing I want to talk about here is bundle size. So really Effect RX is not the problem. It's more like Effect itself. One of the big things that everyone is immediately going to bring up is that Effect 4.0, aka small, is coming. And so this is a new version of Effect where everything is going to be way smaller. This is something they talked about at Effect Days a couple months ago. And if like bundle size is what's kind of keeping you from using this, like I would definitely check it out then. And until now, I will say it is kind of heavy. Now, I don't think that it's that heavy, especially when you consider that, I think in the smallest example, it can kind of be a lot. So I prepared this example if I pull up Ghosty. So I have two things. So I have effect and non-effect. So let's just look at non-effect briefly. So this is just a basic TRPC app. So we have like a TRPC and it has a router, and then we call TRPC on the client, and we have this like use query. And if you notice, like the errors, this kind of like opaque error with like just like a default like message or like data, which I think is untyped errors. And so we can go ahead and build this while I look at the effect one. And so here, if we look at the effect one, we have something very, very similar. So on the back, we have an RPC with a schema, and then we have a handler where we call the exact same API. And then we, on the front end, we kind of put this in an RX, which I can go through in a second. And then on the front end, here in app, we call this like use RX value, and we get back this result, which has like a loading state and a success state and an error state. And if we build this one, and so if we put these up side by side, you'll notice that the effect one is quite a bit bigger. Like it has 3 times the first load.js. And for you might be like, whoa, like that's a deal breaker. Like I cannot do that. And I think the response to that is that effect is kind of preloading a lot of things that we think you're eventually going to need. So in the most basic example, yeah, it's going to be a lot smaller. But as soon as you start adding, like validation libraries and retry libraries and telemetry libraries and stream libraries and all the stuff that effect kind of brings in for you by default, we think they'll probably end up around the same. But if this might break the bank for you, and that's totally understandable. Again, Effects 4 is coming, but it's not here right now. And then the last thing that's worth mentioning on bundle size is this thing called micro. So micro is this library that was made, it's kind of a smaller module in effect that is made to be kind of a slimmed down bundle size optimized version of effect. So if you're using like RPC and you want to use the RPC in the front end, like that's not going to work with micro. It's like very specific use cases where you can still get like dependency injection and typed errors, but without importing the whole effect runtime. And micro is actually what the new version of effect is basically going to become. Like a micro is going to be effect in the next version. But if you're really worried about bundle size, but still really want to use effect, that's something you can experiment with. And then the way I thought I would end off this video is just kind of like giving you a tour of RX and its like basic concepts. And so if you're familiar with Jotai, this will kind of follow a lot. So we can start by actually not using effect at all. And we'll just look at like core RX, kind of like reactive state. So we can start by like creating a count RX. And we can make this with rx.make. And we're just going to start this with 0. And this will return an RX writable. And so we can start by saying const like count, set count. And then we can look at that. There you go. Thank you, cursor. And so an RX is a like reactive piece of state. And so a writable is an RX that you can read from and write to. And then there's these hooks called, so there's like use RX, there's use RX set, use RX value. And what these do is they give you back the value and then a function to write to the value if it's a writable. And we can make derived RXs. So we can say const double count RX, and we're going to use rx.make, and then this gives us a function called get. And then we can, there we go. So we can use get, again, very similar to Jotai, to get the value of count RX and then return a new one. And you can see that this one isn't writable because we can only read from it. And so now if we get double count and we say double count, then look at that, derived state. And so this should be, there we go, use RX value, there we go. And what this is doing internally is like when you call get, it subscribes double count to this kind of count RX, so that when we update count RX, double count updates as well. And so now we can start to look at how effectful RXs work. So if we create, let's say const, let's actually get our one from earlier if I could find it. So here we have our get post effect. And so I'm going to make one called const get post RX, and we're just going to make one from the get post effect. You notice that when we make an RX from an effect, we get back an RX of this type result. And we'll talk about result in a second here. And you also notice that result is typed with the error type. So if we get the posts and we use Rx value posts, and then you'll see that, wow, look at that. It just works. That's pretty cool, right? So you don't have to worry about the runtime. You don't have to worry about running effects. You just make an Rx from an effect and it works. And here, if we do something that makes it like take a bit longer, like we wait, there we go. You'll see that we get a couple different states. And so if we look at the result type here, I'm going to see that a result is made up of 3 possible values. So we have an initial, a success, or a failure. So we get back this result type, and I think the best way to like look at how the result type works is we can like make an example where we call result dot match. And so we can match on the post result, and we can give it like a on initial, and we give it an on success, we can give it an on failure. And the other thing is that this will have like, these all have like a weighting. So these are like the 3 different kind of union variants of the result type. And so initial indicates the initial state, and waiting indicates whether the result is running in the background, right? So this is like in React Query, if you like have some data, but there's a refresh going on in the background, then I think it's like is fetching or is revalidating, and that's basically what this waiting is. And then the error, you'll see that we get a typed error. And it's actually a little bit, if we do this like match with error, you'll see that we get a type error because we also need this on defect. And this is because, again, effect distinguishes between expected errors and unexpected errors. So this error is a typed error, which comes from the type of our effect. But a defect is typed as unknown. But there's all kinds of options, right? And you can also use Rx with suspense, for example. So there's like use Rx suspense, use Rx suspense success. And so here we can like suspend until we get the value. And if we do that, I think there's also an option called like suspend on waiting true. So this is, it will suspend if it's revalidating the background rather than kind of giving you the old value back. And then there's also like options where you can have it, like I said earlier, you can throw on a defect to catch an error boundary where you can like catch the typed error within the component. And I have like a larger example here on /async. And what this is doing is this is getting end-to-end type safety with RPC. So we declare this RPC schema, which has a success of a to-do and a error of this get-to-do error. And these are all built in effect schema, which is really cool because you can define arbitrary kind of serialization and deserialization logic in the schema itself. And then this is where we implement that function. So we call get to-dos, and then we parse them with the schema, and then we map the error to this error. And then here we use this function called Rx runtime, right? Because the constructing the RPC client is effectful, and it also requires this like protocol layer. And so we can combine these all into this layer that produces an RPC client. And we can use rx.runtime to create an Rx runtime that provides certain services. So now if we have an effect that requires these services, like so here we're consuming the RPC client tag and then calling the get to do by ID RPC, we can create an Rx. So this is instead of like rx.make, like if we did rx.make here, we would get a type error because we should get a type error. Or I think it actually, yeah, it just like doesn't work. It gives you the effect back. It doesn't, because only effects that don't have any requirements can kind of work with Rx if you don't use a runtime. But here, if we use the runtime, then we get back this Rx result of the fully typed RPC client error or get to do by ID error. And then if we use that, you can see we can do this like really cool pattern matching where on the error, we can pattern match on the different error tags. So this is the RPC client error, and this is the get to do by ID error. And remember, these are errors that are coming from the server. And we get full end-to-end type safety with both successes and errors on the client. And one last thing I wanted to show here is how you can compose different RXs together that are these Rx results without having to like manually handle all of the like loading or error states yourself. So what we can do is we can create this const like double post Rx, and we can take the get function, but instead return a effect. And so first we can use get.result, which is going to take a Rx result and return an effect that kind of has the success and error type of that result. And then we can return just like the array of posts plus another array of posts. And so then if we get double posts and then get the length and the double length and refresh, look at that. Very cool. So you can compose just as easily as you can compose effects. You can compose these RXs that are made up of effects. And I didn't show it off here, but I think I mentioned earlier, if you have like effect streams, RX works really well with that. If this kind of piques your interest, I would love for you to check out RX. It's like still pretty small, pretty understandable. There's a lot of opportunity to contribute and add features and fix bugs and find bugs, as well as kind of shape the API while it's still kind of in this early stage. So I would love for you to check it out. So I know this is a lot, and if you look at all this and you're like, I don't want any part of this, this looks too complex, totally makes sense. One of the great things about Effect is that it kind of can meet you where you're at. Where if you just want to use it in one part of your code base or you just want to use it in one function, you can very easily integrate it. And I understand that kind of bringing it on the front end, it has a big cost in terms of like complexity and understanding libraries and kind of hooking and handling like front end state and bundle size. But I think if you're really going all in on Effect, which I am, and I know lots of other people are, I think it can make a lot of sense in terms of like just leveling up your entire stack in terms of like tracing and telemetry and typed errors, and you just get this huge compounding benefit. And if you're going to do that, I think experimenting with Effect RX is really exciting. And yeah, I know that was a lot. The front end is complex, and Effect is even more complex. And when you combine the two, it's just complex all around. But I hope that kind of helps kind of break down where Effect makes sense and doesn't make sense. And if you want to use it, what are the best ways to? This is still a kind of rapidly evolving space. I'm sure there will be a lot of kind of innovation here, and I'm excited to see how it pans out. So if you're using Effect on the front end, you should comment down below what you're doing, and we can talk about it. So thanks so much for watching, and I'll see you in the next one.